So, hello everyone, welcome to my talk where I will show you how to use Project Panama to build your own file system. So, the goal of this talk is to show you how you can integrate almost any C library into your project with just 3 simple ingredients. So we're going to do some memory management, we're going to make some down calls to the C code, so going from Java to C, and we're going to make some up calls back from C back up to Java. So what I really want to show you is that you can build really awesome stuff with just integrating some C libraries. So Project Panama wasn't the first thing that you can use to integrate some C library. So has anyone used JNI before? Okay, a couple of hands. And of those hands, who of you did actually enjoy using JNI? That's no one. So yeah, I completely share those feelings. So I'm very happy Project Panama came around, which made building this whole file system a lot more fun. So I hope that you will, after this presentation, you're going to integrate some C libraries during this weekend. So why would you care about Project Panama? So there are lots of libraries out there, especially for Java. It's a huge ecosystem, and there's probably a Java library out there for the thing you want to build or to support you what you want to build. But so is C. C is a very big ecosystem with lots of libraries for very specific things, and some things you might not able to do with just Java. For example, there is I/O urling if you want to asynchronously read a bunch of files using a Linux system or anything with a file descriptor really. There is Fuse. The thing we're going to do today is just build the file system. You can do some awesome stuff. You can communicate with your keyboard. This is a side project of mine where I want to communicate with my keyboard using Java and some C to do some cool stuff. And of course, AI. Python offloads a lot of its code to C because it's more performant. So there's also lots of C libraries out there that will support you doing that. And there is, of course, the performance aspect to it. C is a very performant language. So to show you how performant it was, is that I built, a little demo where I tried reading a bunch of files using the standard API that Java provides me, like the buffered reader, the file reader, the channels. But I also wanted to see how fast I can do it using a C library. So with the red underline, you can see that using I/O urling, I can read a bunch of files faster than anything Java provides me out of the box. And that's the cool thing. In just 2 nights of work, I can create something that's faster than you get default by the GDK. So that's, I think, is awesome, but it's very specific, but you can make it a bit faster. So let's focus on Fuse, the thing we're going to integrate today. So in a nutshell, this is what Fuse does. When I fire a list command in my terminal, it will end up in Fuse. Fuse will receive this message, and it will pass it along to my Java application. So my Java application will create a response. It will pass it back to Fuse, and then it will end up in the terminal where I fired off my list command. So the whole thing is that I can now, using this middle layer, I can integrate with some C library, and for the user, you don't see that you're actually talking to a Java application. So how are we going to integrate Fuse in our Java application? So it's a C library, and it provides us with a data structure that we can fill in with pointers to our Java methods. So you can think of it like an interface. We get this data structure, and it can contain a bunch of pointers to Java methods. We fill in those pointers, and then we pass this object to Fuse, and then Fuse will start running. It will mount itself to a directory of our choosing, and then when an action happens, for example the list command, it will fire off the read directory method in our Java application. So then we got the complete circle. So we are going to make a down call using a struct that we fill in, and then it can make some up calls back to our Java application. So then we got all the ingredients that you need to integrate almost any C library. So let's switch over to some code. And let's zoom in a bit as well. So I already did most of the scaffolding because I have only 45 minutes left. And so this is a very basic file system. So I already have a list of directories. I have a list of files. Those files can contain some bytes. And there is this arena that I will explain in a bit. Then there are also these methods that you need to implement to get a functional file system. So we're not going to do all 7 of them because that's kind of boring. So we will only do 2 of those. So I already implemented them. And these are the 2 we're going to implement ourselves. We're going to do some reading from a file, and we're going to make the create directory method. And then there is this struct that I will also talk about in a bit. So let's start with the first part. So to start views, we needed to pass it some arguments. So I'm going to create a string array that I'm going to fill in with some strings that I want to pass down to views. So I want it to run in the foreground, so I'm going to pass it -f. I'm going to say -d for debugging mode, so I see everything that happens. And then I'm going to give it the location that I want it to mount to. So in this case, it's going to mount to the test directory inside my home directory. So with this done, these strings now live in the heap, but they aren't accessible by views yet, so we have to make them safe to pass them down to the C method. And to do that, we're going to use a arena. So a arena allows me to allocate a continuous region in memory. So I'm going to use the arena of shared. And the arena of shared lets me control the lifetime through this try with resource statement, because there are different types of arenas you can use. So I'm going to use the of shared, and like I said, I now control the lifetime using the try with resource statement, and it can be shared with multiple threads. So this arena can be shared between threads. Then there's also the of confined, which also lets me control its lifetime and can only be accessed by the thread that created it. Then there's also the global, which has an unbounded lifetime. And there is the of auto, which is managed by the garbage collector. So I'm going to use the of shared, and I'm going to just quickly set this global variable. And then it's time to create a memory segment to allocate, to store those pointers. So a memory segment is this continuous region in memory. And this is something that I can pass down to my C method. So to create the memory segment, I'm going to use the arena.allocate. And I'm going to say I'm working with an address. So I say that I use the value layout.address. And then I say how many addresses I'm going to store inside of it. So using the arguments.length, I create a memory segment that can hold 3 addresses, each for one of those strings in that string array at the top. So the next thing I want to do is to actually store those strings inside, or just create those pointers and store them. So let's do that using a for loop. So I'm going to create a memory segment called cstring. I'm going to say arena.allocate from, which is a handy method that allows you to allocate a memory segment using a string. So I'm going to pass it the correct arguments that we are working on. I'm going to say pointers.setIndex, so set at index. So what I want to do is to set the address of that C string memory segment inside that memory segment called pointers. So I'm going to say that I'm working with the value layout address. This will help you with the offsets. And then I'm going to say where I want to place it, and then the value I want to set it to. So it's smart enough to know that it needs to get the address of the C string. And that is it. Then we have a memory segment which holds a pointer to those strings, so we can safely pass that to our views method. So the next thing we're going to build is the linker, and the linker is something special. It does the heavy lifting when we want to make a call to our C method. Because the linker knows what the calling conventions are of the C library on your particular system. So the link, when you create a link like this, using linker.native linker, you will get a linker that is specifically for your operating system and CPU, so of which the JVM is running on. So this linker will allow us to create some upcalls and some downcalls later on. And then I'm going to create a symbol lookup. So the linker can already find some standard C methods which are normally available on the system it's running on, but Fuse isn't really that much of a default, so I have to load it myself. And to do that, I'm going to use the symbol lookup. So I'm going to create the symbol lookup, because I could also use the system.load library, which has some downsides. So that's why I really want to use the symbol.lookup. So I'm going to use the symbol.lookup.library lookup method, and then I'm going to pass it the correct library, which is located in this location. And then I'm going to connect its lifetime to the arena. So the great thing about this is that now our library will be loaded during the entire lifetime of the arena. So when the arena closes, my library will be unloaded. So it's only available when the arena is. So it doesn't take up too much resources when it's not needed. And then I want to create one last thing, and that is an address layout called cPointer. So I found this one in the Java documents, and it allows me to create this special address. So normally a address you get back from a C method is just a memory segment with no size. Its size is 0. So a memory segment with a size of 0, you can't actually read or write to it, or read from it or write to it. So I'm going to need an address with a specific target layout. So I'm going to say this address has a target layout of the sequence layout, because what I want to create is a sequence which is almost infinite of Java bytes. So what this does is that this C pointer will now point, or thinks it points to, a infinite amount of memory. So now I can safely read and write to it. And this is all we need for the setup of Fuse. So the next thing I want to do is to actually create that down call. So let's do that. So to do that, I'm going to need a function descriptor. So the function descriptor is just the signature of the C method that I want to call. So if you're working on integrating some C library, it's really handy to have the documentation next to it. So I'm going to say the function descriptor of, and I'm going to create or recreate the signature that is known in the C library. So the first value is the value layout.java int, because with the function descriptor, the first parameter is actually the return type of the C method that I'm going to call. So the Fuse main method returns an integer. So my first value inside, my first parameter inside the function descriptor is the Java int, because it returns a Java int. And from there on, it's just the parameters that are the same. So I'm going to pass it another Java int. I'm going to give it some pointers, one to the string array and one to the operations memory segment that we're going to create in a bit. And then I'm going to create just a few more parameters. So with this, I created a function descriptor that I can use, or is basically just a copy of the C method that I'm going to call. So the next thing I want to do is to create a method handle. And this method handle allows me to actually call that C method, to actually invoke it. So I'm going to say Fuse main real, because that is the real Fuse main method. And it's actually also the real name that is inside this library. I like to give my method handles the same name as the C method. So I'm going to say linker.downcallHandle. And what this does is that it allows me to pass it the symbol lookup that knows of views. And I'm going to say find the method called viewsMainReal, or else just throw an exception. And then just pass it the descriptor. So the next thing that's left to do is to just invoke that method. So I'm going to say viewsMainReal.invoke, and then I'm just going to pass it the arguments that it needs. So the arguments.length, a pointer to those arguments inside that string array, then the operations memory segment that I'm going to create in a bit, and then the operations memory segment dot byte size, because it needs to know how long the previous pointer was, and then a memory segment of 0, because that method or that parameter isn't really needed. So from this point on, we actually called that viewsMain method. So to call a C method, you need to create a function descriptor, which is just a copy of that signature, and using the method handle, you can find that C method and invoke it later on. So let's continue with creating the upcalls. So to create the upcall, we need for so let me just type this. So for views, we need to actually fill in this data structure, this struct. And that is the struct which looks like this. So views provides its users with a struct it needs to fill in. So with a normal C library, you would just use that struct, fill it with pointers to your C methods, and you're good to go. But because we're working in Java, we need to do something special. We need to actually recreate that struct inside our application. So I'm going to use the memory layout.struct layout, and it allows me to recreate that struct, so which is basically just a bunch of addresses. So I hope you understand why I'm not going to type this on stage. So all I need to do is to fill in 6 or 7 of those methods. So let's do one, which is the first one, which is called the getAttribute. So I'm just going to fill this one in. So the first thing I need to do is to actually create a memory segment that can hold all of those addresses. So I'm going to say memory segment, and it's going to be the operation memory segment. And I'm going to do arena.allocate, and then I'm going to just call that method which contains all of those addresses, that entire struct. So using the arena.allocate, I have a continuous region in memory which can hold all of those 25 addresses. So the next thing I want to do is to create a method handle, but this time it's not going to be for a C method, but actually for my Java method called getAttribute. So I already implemented that method here. So the next thing I want to do is to actually create a method handle for it, to later on create a stub for it. So I'm going to create a method handle. So I'm going to say method handles.lookup. I'm going to say find the static method inside the viewsDemo class, which is the class we are working in. The method is called getAddress, and the signature of this method is as follows. It returns a Java int, and it takes 3 memory segments as its parameters. So, and just one more. So now I got the method handle. The next thing I need to do is to create another function descriptor. So this function descriptor is basically just a copy of that method handle or the method type, because it's needed to create the actual stub. So basically I'm just going to say function descriptor of, and I'm just going to say that it returns a Java int, and it takes 3 memory segments, but this time the C pointer type. That's one too many. So all that's left to do is to actually create that stub now. And this stub is just basically a memory segment that we can later on pass to the viewsMain method. So I'm going to say I create a memory segment. I'm going to call it handler function. And I'm going to say linker.upcallStub, because I want to create a stub that C can safely call. So I'm going to pass the getAttribute, the function descriptor, and the arena we are working with. So, just a bit too much. So the next thing I want to do is to create the, to actually set that handler function inside the struct that I created, or the memory segment which contains that struct really. So I'm going to use the set method. I'm going to say that I'm working with an address layout which is located here. And I'm going to select the group element called getAddress. This is the location I want to place it, and this is the memory segment I want it to point to. So now we just wrote a bunch of code to create one down call, which was all of this. We need to create a function descriptor, a method handle, actually invoke that method, and to create an up call, all we had to do was just create a method handle, a function descriptor, another memory segment, and to actually set it. So this is a bunch of code, especially if I have to do it 20 more times to fill in that entire struct. So I want to show you something different, an easier way of doing that, which is used, or I use Jextract. And Jextract is this really awesome binary that you can find on the jdk.java.net/Jextract website. And what it allows you to do is to create or to generate those bindings for the C library that you want to integrate. So gone are the days that you had to just write all of that upcall and downcall stop methods. I'm just going to use Jextract. So I already did this for this Fuse library, and that command looked a bit like this, or it really looked like this. So I'm going to use the Jextract binary. I'm going to pass it -d for the macro, because to use it I had to use the Fuse, to set this Fuse macro, which is called the Fuse use version is 35. So after setting the macro, I wanted to say where the output was going to be placed, so that's what the minus output is for. Then the -t to set the target package of those generated classes. So in this case, I wanted them to be org.libfuse. Then -l for the library that I want to load. And then the fuse.h header. This is the header I'm going to actually create those bindings for. So when you have done this, what you end up with is just a bunch of class files, and these are Java class files, but they don't scream Java. They have these lowercase letters, these underscores. That's not really conventional, but I promise you they are filled with Java code. So when you look inside one of those libraries, you will see something like this. And that is that the code it generates really looks a bit C-like, is that this is the Fuse main method, and we can work with ints, but the rest are all memory segments. So there's no nice string arrays, no objects that I can pass. It's all memory segments. So the code it generates is very C-like, and what you really want is another layer on top of it that you need to recreate yourself, because giving this to a colleague isn't that much fun. So you really want to add that extra layer on top of it, which translates objects and string arrays to those memory segments to actually create some nice bindings for your C library. And one other thing is that Jextract only works for true library symbols. If you have a method which is a static inline, then it isn't going to work. It's just going to ignore that method. So that's something to keep in mind. So let's switch back to the code, because I want to show you how this looks if we are working with Jextract. So I'm just going to copy some code in there. So as you remember, all we had to do for the setup of the upcall stop, we had to do all of this. So with Jextract we can create really just one-liners, which is really great. So it really saves me a lot of code that I need to maintain, that I need to write. So Fuse operations, so Jextract regenerated that struct at the bottom. So this struct was recreated by Jextract inside those generated classes, and it also gave me some nice handy methods for me to use. So each of those addresses get a setter, a getter that I can use. So in this case, I'm going to use the set method called read there. I'm going to say which memory segment I wanted to operate on. And then using that same struct, it allows me, or that same class, it allows me to create that upcall stub. So all that code is generated for me, and I only have to actually just call it. So the allocate, it takes a lambda expression to my Java method, and it will create a stub to this method. And I'm just going to say this is the arena I'm working with. So with all the upcalls implemented, I also want to show you how the upcall or the downcall looks. So as you remember, all of this code was needed for the upcall, or for the downcall, which can also be turned into just a single one-liner, which almost feels like a real Java method. Fuse underscore h is the header file, which it generated this Java class from, and then I just have to call the fuse main method and pass it all the arguments that it needs. So let's continue with implementing the last two remaining methods. So just going to remove this one. So the first thing I want to do is to know the path that I'm working with. So I'm going to get the path of the memory segment. So Fuse already provides me some arguments, like as you can see here, there's something I took from the documentation of Fuse, and you can see it takes the char, which is the path, pointer to a char array, which is the path, a buffer, a size of that buffer, the offset, where do I want to read from, and the some file information. So the first thing I want to do is to actually get the path that I need to read from. So I'm going to use the getString method and just remove the first character. So the getString method allows me to just read a string from a memory segment, which is just a really handy method. The next thing I need to do is to check if it's actually a file that I'm working on. So I'm going to call this method called isFile, and it returns -1 if it isn't, which is a basic convention in C, is that if it's unsupported, then you just return -1. So the next thing I need to do is to know which bytes, or to get the bytes from the file that I need to read. So I'm going to use the file content, which is a map, which maps a path to a byte array. And using the byte array, I'm going to just store a quick reference to it. So then I want to create a byte buffer, but not just a byte buffer, but I'm going to use the memory segment called buffer, and I'm going to call the reinterpreted method on it. So at the start, when I get this method, this is a pointer to a memory segment. And as you remember, a memory segment, which is a pointer, has a size of 0, so I can't actually read or write to it. So to read from it, I need, or in this case to write from it, I need to reinterpret its size. So it's nice of Fuse to give me its size, and I need to call the reinterpreted method on it, which will create a new memory segment with the size that is known. So I'm going to say size. So at this point, I have a new memory segment with the correct size, and I'm going to say act like a byte buffer, because the byte buffer has some nice handy methods that I want to use. So just now this byte buffer is actually backed by a memory segment. So the next thing I want to do is to create the byte buffer, or create the byte buffer.put. I'm going to put the selected bytes in there, the offset which Fuse provided me, and the selected bytes.length. And then I return the length of the size that I've written to it. So the next thing I want to do is to create, to implement the create directory method. So I'm going to do the same trick again. I'm going to get the path, and then just quickly add it to this map with the other directories inside of it, without the first character. And then I'm going to return 0. So this last method is really to show you that not all of those methods are really complicated, to not scare you away. So the next thing I want to do is to actually run this. and hope that it works. So I'm just going to run Maven package. And it looks like it built. So the next thing I want to do is run. So you can already see some output of views. So let's see if this file system is actually up and running. So let me just clear this. So the views already mounted itself to the test directory inside my home directory, which is where we are. So I'm going to just change directories into that. And as you can see, views already output something to the console to show you that it's working. So let's create some directories. So I'm going to create 1. I'm going to create 1, 2, 3 directories. And when I do the list command, you can see that they are all there. You can also create some files. So I'm going to create file 1. Say hello from C, because this is the C code calling, making the upcall to my Java code. So I'm just going to store that one, and as you can see, when I reopen that file, it's still there. So our basic file system seems to be working. So I'm just going to move up one and going to unmount this directory. So when I do the list command on the test directory, you can see that it's empty. So Views now unmounted itself from the test directory, and our Java application, as you can see, also stopped running. So let me switch back to the presentation. Yeah, so before you go, I want to give you some performance tips and tricks. So one of the things you really want to do is to reuse those method handles. Recreating them, finding that symbol inside that library takes up quite some time. So if you can reuse those methods, it's can really save you some time. Also reusing memory segments, which is not always preferred, because there is the chance that you will pass or forget to clean that memory segment before passing it to a new user. So only reuse them if you dare. But yeah, if you are confident that you can, then yeah, it might save you some time. Also allocate memory segments and those method handles as well when time doesn't matter. So on the startup of your application and not during the actual call that the user is going to do. And of course, knowing some C is also going to help you a lot, because sometimes Jextract will throw some error, and then you know how to fix it, or you want to make a call to just a single library, forget about Jextract, and you need to know how that library works inside. So only use these tips and tricks if they are worth it, and always measure the performance before starting actually implementing those. So I want to thank you for being here. I hope that you're going to create or implement some C library into your project, or at least try to create some bindings, which is quite a fun project to do. The source code is in the QR code or on GitHub, and this is the URL to it. So I want to thank you, and yeah, have a nice trip home.